Hey everyone, let's look at number 3 in section 5.8. We're going to evaluate the following definite integral. Um, and the answer we get is just kind of interesting as far as after simplifying it. And so we'll talk about that here in a minute. So first of all, we're going to do this by substitution. And remember when we see dt over 2t plus 2, really what we're finding the antiderivative of here is 1 over 2t plus 2, and this dt is just telling us the variable of integration is t. And so how can I do this? Well, I'm going to let u be the denominator here. Hopefully you can see what's going to happen here. If u is 2t plus 2, of course, the derivative of 2t with respect to t is 2. So I get du is 2 dt. And you say, well, I only have 1 dt. Well, that's easy. Just multiply both sides by half, and I get that. And so what form are we going to get? We're going to get 1 over u du. And we know, hopefully, what the antiderivative of that is. But this is a definite integral. And so we need to also change our limits of integration. Very important that you do that, right? So how do I do that? The lower limit is t, right? When it's t is 4, plug that into here, and I get 2 times 4 is 8 plus 2 is 10. U is 10. If t is 14, plugging that in gives me u is 30. And so it's real important when I transform the variable from t to u that I also transform the limits anytime I'm doing a definite integral. And when I do that, what do I get? Well, the again, the dt we said is 1/2 du, so I'll pull that 1/2 out, du, and then I have 1 over what? U. So 1 over u du or du over u. And then notice the limits of integration. 4 was our lower limit, but now it's 10. And again, 14 was our upper limit, but now it is 30. So this is the form that the integral becomes, and we never look back. So here it is in t, here it is in u. We're going to stay in the u variable and not go back to t here. We don't need to know, you can write out if you want to what the antiderivative of this, of this function right here is in terms of t, but it's really not needed here. What's the antiderivative of 1 over u? Well, it's the natural log absolute value u. So I've got this 1/2 times the natural log absolute value u. Evaluate in the upper limit of 30, lower limit of 10. So don't forget, when we evaluate, we don't have the integral sign anymore. We have the evaluation bar, and it's on the right, meaning we're going to plug in u equals 30 and plug in u equals 10. And that's why it's real important to change these limits, because these are u limits. You can't use the 4 and the 14. Those are t limits. Those would not be, that would not be correct. So 1/2 natural log, what? Evaluated at 30. Of course, absolute value of 30 is 30, and then absolute value of 10 is 10. So here is the result. Now, here's what's interesting. If you remember, the property of logarithms has that if I have the logarithm of a quotient, it's the difference of the logarithms, right? Remember logarithms being exponents. So when I take the log of a quotient of two expressions, what's that exponent going to be? We subtract the exponents. Well, I'm going to use that in reverse, right? Here I have like natural log of A is 30 in this case, natural log of B is 10. And so I get the natural log of what? A over B, 30 over 10. Well, 30 divided by 10 is just 3. And so I get 1/2 natural log of 3 or the natural log of 3 divided by 2. Either one of those would be sufficient. So that's a nice simplification for this problem. Um, and again, I'm pretty happy if you get here, but this should be something you get used to doing. And Achieve wants this simplified answer. You can also check this. Remember, of course, your calculator's function integrator won't give you this exact value, but if you take your calculator and do 0.5 times the natural log of 3, get that decimal equivalent, go back not to this one, but to the original definite integral and evaluate that one and make sure the decimal equivalent is the same. Okay, hope this helps on this one.